everyone, we're going to find the radius of convergence and interval of convergence for our series given here. We're going to use the ratio test given here and set it equal to -1 to see if it converges. So we're taking the limit as n approaches infinity. We have the absolute value of a sub n plus 1 divided by a sub n. All right, so this is going to equal, I'm going to do a little side notes here when I'm doing this one. So the limit is n approaches infinity, absolute value, and then we have this -1 to the power of n plus 1. I'm doing the numerator first, times x. And then when you plug in 2 times n plus 1 plus 1, this is going to give you 2n plus 3. Okay, so anytime you're substituting in n plus 1, and this is like your slope here too, all you have to do is add 2 to this. All right, given that, now we have in the denominator, we're going to have 2n plus 3 factorial. All right, now for the second piece, we have to divide by this, which is the same as multiplying by the reciprocal. So this is going to be times 2n plus 1 factorial divided by -1 to the power of n times x to the power of 2n plus 1. All right, now let's simplify all this. So for this part here, this is going to give me the limit as n approaches infinity. And then we're going to have absolute value of -1. This piece here, this is like x to the power of 2n plus 3 minus 2n plus 1. So this is just going to give you x. The 2 n's cancel, and 3 minus 1 is 2. That gives you x squared. Now, for the denominator, we're simplifying this. So what we need to remember is that this equals 2n plus 3 times 2n plus 2 times 2n plus 1 factorial. So what's going to happen is these two cancel, and you're left with 2n plus 3 times 2n plus 2. That's by definition of factorial. All right, now that's my little side stuff there. Let's get rid of that. Okay, next, let's go ahead and pull out our x squared. And we don't have to put the absolute value on it because it's squared. Then we have the limit as n approaches infinity. And also this -1 turns to 1. So we're going to have 1 divided by 2n plus 3 times 2n plus 2. All right. Now when you take the limit of this and substitute in infinity, this is going to turn to 0. So we're going to have this equals x squared times 0, which is less than 1. Okay, so by our ratio test, our series converges for all real numbers x, because we have this 0 here. So it's for all real x. So your radius of convergence equals infinity, and your integral of convergence is going to be from -infinity to infinity because it's all real x. Thank you. Have a nice day. Bye-bye.